So welcome everybody to this afternoon session. My name is Adrienne. I'm going to lead you through these two talks before a small break. The first one is by Lluís Breton. He is a researcher at the Center for Ecological Research and Forestry Applications. And he has in his own lab, the Landscape, Ecology and Biodiversity Lab. And from the name, you can understand already that he's going to look at biodiversity responses. And what is interesting, he's going to look also at the past, but he's going to use that past to predict future change under land use change, climate change, for example, agriculture intensification, and also disturbance regimes. That's what he's going to talk about today in his talk about rethinking the role of landscape disturbance dynamics in a changing world.
Thank you, Adrienne. Well, thanks for being here now, and especially thanks also, Sandra, for inviting me to this fantastic day of landscape ecology and research, and with all of you in this fantastic place. So thank you, and I will open more explicitly the role of disturbances here in this talk, and more explicitly that of fire. Will be concentrated out of fire, because the disturbances are key for biodiversity dynamics, are one of the major drivers of this change of this dynamic perspective that we have been hearing today. And since disturbances are changing, so we need to understand how these environmental conditions that are changing shape these disturbances and how a species respond to that. And my talk will concentrate on that, but also on how to mobilize this information about how disturbances work and how to restore those disturbances in the current biodiversity crisis, and to which degree this knowledge and this potential restoration of the disturbances can be implemented with an example in which we have been participating. So first on disturbance ecology. So disturbances in general, I will be focusing mostly on fire, but you can take that quite generally. They are events that change the structure of a habitat, of an ecosystem, and disturb the state in a sudden way. So you can have here, for instance, the print of two fires in different time steps that have left that imprint, and that means that disturbances like fire, for instance, they are key ecological processes. They actually interact with other ecological processes to determine what we might find in a place. So first, because they produce this selective filtering in which species, individuals die. So if they have some kind of adaptations to withstand the fire, they might survive, like sprouting or some others, or escaping if they're animals. But also after the fire, in this case, or the disturbances has been impacting in a place, species with different traits might respond to that opportunity and seed and colonize this area. And also, depending on how in time and space these disturbances affect, that means that these kind of pressures that the disturbances exert on a site will interact and will accumulate. So they will be shaping the way communities and species respond to these disturbances. And species actually come with different sets of traits that might be shaped explicitly by fire or other disturbances or other evolutionary processes. But this kind of combination of sets and traits will actually allow them to respond in a way to either reduce vulnerability to disturbances like fire or increase resilience after these disturbances. And that means that at the end, fire interacts with all these other ecological processes like dispersal, other like breeding, other kind of more population level processes, trophic complexity. These linkages across trophic levels, those will interact to actually shape finally the kind of communities and the responses that we see in a particular place. But for that we need to understand disturbance dynamics. I will concentrate with different examples from Catalonia, the place where I've been working around Barcelona in this area, where we have been working a lot on fires and birds as study examples. And first, a bit of an idea of how fires have been changing in the last decades in this region, because as I was saying, like disturbances like fire are changing quite remarkably due to human activities and human control of the systems. In this case, first, that's how the forests look now. Many of you might know there's been a lot of land abandonment in Mediterranean areas in the last decades. So that's a legacy of old use. It's not only about the direct human control. Even when you live or you relax this human control, there are legacies that stay in the system. And that leads, of course, to fuel accumulation and more vegetation in the landscape. And that's because of a collapse of a traditional system that was based on grazing and use of forest products like vegetable coal and also the abandonment of terraces, of agricultural areas in this system. And this has led to an increase in fires that leave a very kind of a visual and evident fingerprints in the landscape. Those are the landscapes, the fires affecting the fires affecting Catalonia in the last 30, 40 years. And you can see here, so this is the early part of the 20th century, where there were more or less, well, little fires actually, and that coincided with a high population of rural population in the region, and a decrease of this human population linked to an increase in vegetation and increase in forests. This produced a change in the dynamics of the systems, the fire regimes around the 70s. But this has been linked to an increase of these forest fires, and with peaks in years like '94 and late 80s and 90s, and the developed responses in terms of society, especially in terms of implementing very effective fire suppression systems with firefighters, etc. That first reduced the number of like medium-sized fires, especially the medium-sized fires that affected most of the years, and then more recently even like more extreme fires. So that's changing a lot the stochasticity and the imprint of fires in the region. So fire is changing in these ecosystems and changing mostly to human intervention and control for different reasons that interact in the landscape. And so what is the effect of this reconfiguration on biodiversity? Can it be predicted? And we did that with our studies on birds. So coming back a bit to the role of fires in these systems, in terms more like now like applying, I mean, these examples of traits and fire fundamental processes determining how a species will respond. We have this kind of gradient from the initial state of the forest after the disturbance, the recovering open stage, and then the habitat recovering as vegetation matures and succession advances. And of course, to actually get totally encounter the specific species in each of the places, you need different processes that are acting. First, you need to have the right habitat, and there are resources in each of the sites that are changing quite rapidly according to the distribution, but also the species need to find those areas. They need to immigrate, they need to disperse and get those areas, and in some cases they could even like through process of philopatry stay very long after the changes in habitat have progressed. So using this kind of processes, we've concentrated a lot on dispersal and changes in habitat, and we have been sampling different recent fires around Catalonia to understand what would be the species colonizing those areas, what would be the processes there, and what would be the limitations of dispersal and different and other factors. So, because we know that from Atlas data, from comparing data and distributions on these open habitat species, from the late 80s, early 80s to the beginning of the 21st century. We know that range expansion in these open habitat species have been increasing in spite of the fact that there's been a lot of abandonment, and this is related to the fires. So using this information from the Atlas and the DINDIS database monitoring, which is this specific monitoring on fires, we conducted some of these studies. First, we know that there is a lot of diversity in this post-fire, so we find like that different communities of these open habitat species according to this, so that this is related a bit to the habitat amount and the heterogeneity hypothesis that in the fire wall we call more biodiversity. So the more richness you have in terms of conditions, on post-fire conditions, or on conditions affected by different fire regimes, the more post-habitat fires, habitat types you will have, and that will increase like the communities you would find there. And that's what we found in different fires. So the bigger the fires, the more of these habitats we would find. But the second is to which degree this interacts with dispersal constraints. So do we find like all post-fires communities are the same, or they might be kind of dependent on other factors like dispersal? So would be like the fires in this area where we don't have the species close by be different or more easily reachable than in this in this particular fire where colonizing sources are very far away. So we're trying to incorporate the dispersal effect on predicting and trying to predict the colonizer sources, the colonizers in these fires that we were sampling. And we found a very strong effect of this. So if this is the frequency of occurrence of the different species of open habitat species that we were analyzing, that are species in general that are decreasing at the European level because of farming abandonment and farming intensity. But these are quite in general present in fires, but not in all fires. So we have this frequency of occurrence in relation to the nearby colonizer sources estimated from Atlas data. I'll show, and there is a general strong correlation. So with the fires with stronger or with higher populations nearby, they have higher frequency of occurrences in those post-fires. So there is an easier way to colonize by those populations. So fires that occur near population sources will be richer in terms of the post-fire. And this is critical because then we analyze a bit more also what would be the effect of connectivity from different types of habitats. And then we assess how these kind of systems are, so the new colonization of these post-fires are related to all fire sites, to non-fire shrublands, so more stable shrubland habitats, and crop farmlands, so farmlands that are also stable in time, because these two are more or less stable in time. Fires are more like dynamic; they appear and they kind of close very rapidly. And then we analyzed like different hypotheses to see which ones of these are actually more related to the communities that we found. And we found that the three are very important, but it's quite interesting because they are not overlapping and they are complementing. And that means that in our system, we are having a more like a kind of a shift towards static reservoirs where these species would use open habitats from farmland and herbivory, like from traditional landscapes that we had before the 50s, to systems that are more dynamic shifts, dynamic mosaics that are shifting now related to fire. And this is something that is quite new, because these dynamic shifting mosaics still to some degree are dependent on the static reservoirs, because there are still some population in static reservoirs that are being lost by intensification and abandonment, and we start like shifting because we have more and more these more dynamic mosaics being created by fire, but they need to be colonized at some point. So if we lose the static reservoirs and the dynamics of the apparition of new fires changes, or it's like stop for some time because of fire suppression, for instance, we might break this system. So to which degree, how could mobilize this information in terms of coming up with solutions or proposals for this, no? Because we know that recent change interactions between abandonment and fire reconfigures those landscapes and the biodiversity patterns associated. So can we use this to mobilize and to maybe restore some the disturbance regimes? So this part is about rewilding of restoration of fire regimes. So the rewilding framework is a framework that is a kind of restoration framework that allows us to kind of restore ecological processes into systems. And it has like three main parts, like restoring dispersal processes, like for instance in a river, like taking out a dam, trophic complexity, like putting back, for instance, herbivores or carnivores, like Jean-Louis just mentioned on systems where these have been taken out from humans, and also restoring disturbances in systems where these disturbances are controlled by human activity. So the rewilding framework is how we could like restore those processes that human activities are not controlling or have been moving to take them out from the system with different effects on those systems. So how we could do it in the terms of the disturbances, because there's been a lot of focus on restoring dispersal and connectivity in the systems, a lot of focus also on trophic complexity, on restoring trophic complexity, but much less on how we restore disturbances regimes, like for instance fires, and so we concentrated on how to do it with fires, especially in terms of how human control these fire switches, so that the elements that you need for a fire to occur, from, of course, specific fire weather, fuel availability in terms of dryness of the fuel to be consumed by fire, and ignition source. You need these fire switches at the same time connected on to have fire. And then we added a fifth one, which is the suppression, which is not usually in natural systems, so it's not something, but it's something that is present in human system, and it's actually also a human way to control the fire regimes. So humans, through anthropogenic changes, have been affecting, like through indirectly through climate change, for instance, or through like legacies, like I just mentioned on land abandonment, accumulation of fuel, changes in ignition sources. That's also a way that humans have used to alter or modify fire regimes. Changing the seasonality or the spatial arrangement of these fire ignitions, fuel dryness also in some cases more locally affecting like the wetness of the systems, and especially fire suppression intensity, especially for instance in the systems that we have been working on, it's very strong, and therefore is in our case one of the major elements in the present human control of the fire disturbances. In this case, it's mostly fuel availability related to land abandonment and the different phases in the strategy that firefighters have been using to suppress more like explicitly or strategically fires in the area. So then, how we could do that? How we could reverse these switches and the human control of these switches, so that we can start like reversing and therefore restoring and rewilding these fire regimes, with some examples like of some possible levers in different contexts. Of course, this is an article that we published last year, was very general for different kinds of fires, but some examples where fuel availability, of course, could be related to herbivory, for instance, target herbivory, and then reversing this human control on fuel availability. Others like ignitions or landscape dryness or suppression could be also like reverse in terms of, for instance, smoothing the suppression in places where it could be positive. So we have this kind of levers that can be that are controlled by human activity and could be relaxed in specific cases. So we could like align some of these. We could align some of these switches in terms of identifying which combination might be potentially positive for biodiversity, for instance, and select some of these rewilding actions, and then, of course, implement, monitor, and evaluate. In the case of Mediterranean landscapes, for instance, what it could be kind of most effective probably would be to target suppression and therefore reduce the intensity and spatial coverage of suppression so that we have more fires of smaller and less intensive sites, intensive places, and then we reduce the probability that we have large fires that actually then have different effects on negative effects on biodiversity, but also on risk. And then the last part I would just like very quickly is that we actually did that. So we collaborated with firefighters in Catalonia, and then we tried to identify ways in which we could like land all this theoretical stuff that we have been working on, and then they come up. Actually, it was with the firefighters. They come up with the idea of environmental flows, like the water flows in a river, so that we got like this idea of fire flow that could come in a landscape. We could correspond to a landscape, and that we could like even measure in specific ways, like seasonality, frequency, capacity, power, behaviors. They could be described for a particular landscape in the sense that it could be then implemented. And then we actually implemented in a county on the Pyrenees, in the Val d'Aran, with the firefighters. So that we had a fire kind of official document where the environmental fire flow and all these kind of naturalization elements of a fire disturbances are written, and in the idea that this implementation gets positive effects for both biodiversity and people. And it was nice because I'm just finishing that the plan was implemented, and then some years ago there was this 3 years ago there was this fire in Canejan, finally 300 hectares, and it was quite funny because the firefighters didn't stop that fire. It was part of the plan. It was an unplanned fire, but it was in an area that had been planned for burning in the future. So it was a positive fire, and it was in the news, and it was quite influential in the terms that it was one of the first places or first times in Europe where in a plan, with a plan perspective, an unplanned fire were let burn for positive effects on both biodiversity and society. So yeah, that's the thing. So we need to mechanistically identify more these drivers of fire regime and identify how they link to society and ecology. And I just want to send a message that we can take kind of actions to restore disturbance and regimes, and that can be a very powerful and complex also tool to narrow a bit the gap between the Western societies and the way they function and natural systems, because we need to link that part. And there are examples, at least the one of this joint work between ecologists in this case and key actors. And it's nice that we can work together and make ecology work in this case. Thanks.